So we are about to start my work on the file motorbike Mauro, which I had just created off the record of the video because I just forgot, but luckily I remembered at least now. So we are about to start with this file, going to the top and exploring the YAML file. It suggests that there is bicycle, motorbike. I think, let's see what's going on. Motorbike Mauro, and here it says bicycle. Is this the file that I want? Country count. Yeah, I think it is. Maybe it's just a problem here on motorbike. Let's render this quickly to see if the output is the one that I expect. I think I forgot to change the title, but I think the document is the right one. Let's see. Yeah, we haven't seen count yet, and rename with. So yeah, we are fine. We're good to go. So sorry for that change. I'm going to do it on my PR. So you may choose to do it too and change the title to motorbike, or you can just leave it as it is, and the change will be reflected. So let's close all chunks with Command Option O or Alt O. The setup that I use is the usual. The packages that I use are the one that are usual now, the tidyverse and a couple of friends, but I'm also using now Glue, which is a package that will allow us to create strings of text, combining literal text and variables. You will see that in a moment. Also, just saying it aloud, I'm moving a little fast. We have, as we move, I kind of promise that the lessons are going to be faster and more challenging. For some, this is, finally we get to the speed that I feel comfortable with, and for others, it's going to be like, oh shoot, this is going way too fast. So, depending where you fall in the spectrum, you may find this too fast, too soon, or probably too fast, too slow, or maybe just right. So. This is a review. We did this already. We create a path through all the files that we want to read. Usually you have all the data set maybe in one file if it's structured in the same way. But in this case, I want to show off the ability of vroom, especially because it's not well documented that you can read many paths and not just one, and it will row bind really a sequence of data frames I have read. It will row bind them all together into a single data frame. So that's a pretty cool feature. So as I call vroom, I also call the function glimpse. So the output of vroom, I pass it to glimpse, and then I save it to messy. And this is because I want to kind of discuss this kind of advanced-ish feature of what it means to return an invisible value and what value should each function return, and to discuss a design principle of the tidyverse. So glimpse is a function that shows something like what you're seeing here on screen. It shows like it's an improved version of looking at the structure of in this case glimpse works with data frames. But it is primarily called for its side effect of printing something to the screen. So the purpose of that function is not to compute anything on your data. You're not wanting to change your data in any meaningful way. You just want to look at it. So the tidyverse, because it's so focused on piping operations, so you can compose functions with the pipe, has this design principle that says that whenever a function is called for its side effects, like for example printing something to screen or saving a file to your computer system, then it should return something. It should return the first argument passed to it so that it can itself pass it along to the next function in the pipe. So here we don't have a pipe that is too long. It just dies here, ends in glimpse. But yet it is useful that glimpse returns its input. So vroom path is passed to glimpse. Glimpse does its job, printing stuff to the console, but it returns its input intact. That means that now Messy stores the actual data frame and doesn't store, the representation that Glimpse produced of that data frame, right? So that makes it very convenient to use, like in the middle of a pipeline, or just as I'm doing it here, to glimpse as you read. Because having a glimpse of your data is such a common problem, just a common task. before you start actually working with it. You want to understand what are the types of columns that you have, which are the names of your columns, which are the few first values of each of them. So there you go. So the idea of returning invisibly and why do I say invisibly? Because if I print this, if I run this, what we see is the output of glints. It's not the real. So it's the print, the side effects of glints, not the actual return value. The return value is invisible and is passed. In this case, is stored in messy, in the variable messy. So if you felt that was a bit too fast and you don't know how to eat that stuff, that's because the idea of how you design functions so that they feel good for a user is something that mostly developers care about more than analysts. For you as an analyst, maybe it's just good to know and maybe curious why some functions return a value that you can retrieve if you store it in a variable, but you can't see it printed on the screen, and that's why. So a common way to explore data, after you glimpse it, is to count stuff, to count rows, for example. We have this, experience with this data set, and we know that there is one row per country, but we may not know that up front. So the very first thing I could do, I would, just start from in this case, from the left, so I can count continents and count. So count is a shortcut, really. So if you see the help file, the definition of this function has x as the data set that you're passing. It says here in the data frame, but then it has any number of grouping variables. So you could call first group by and then count, but you don't have to, because counting is such a common task that they decided to provide a shortcut. So basically, you just count continent. What it's doing is just counting the number of rows by continent. So this could be the same as doing something like this. It's just a shortcut for doing this, right? But it's such a common task that maybe a shortcut is welcome. You can print that too. So shortcut there. The second thing we might want to count is country. Oops, count country. So that's fine. When you run that, you see that every country, at least the one that's printed on screen, have only one row, meaning that this data frame, it looks like there is only one row per country, right? That's what we're trying to figure out. But there is only so much we can see on the screen, 10 rows only, and there is many more rows. So we want to kind of answer that question: does this data frame have exactly one row per country? In a programmatic way. So one way could be to filter now this data set with the tools that you already know from the tidyverse, and ask, give me the rows where the column n is greater than 1, and we expect this to be none, right? So if our prediction, if our hypothesis is true that the data set contains exactly one row per country, then running this should give us an empty table, which is the case. So this is the table that has no rows. It still has the columns that it has, country and n, but there is no rows because there is no row that meets this condition here. Moving next. So what we have here is a messy data set as we defined it in the tidyverse. If we want to work with this as a variable and years as a variable too. So that means that many of the tools that the tidyverse provides, like for example ggplot2, cannot work fluidly with this kind of data, and usually you could just reshape it. But as a way to show off the ability to work row-wise, I'm going to perform an awkward analysis that hopefully will demonstrate the row-wise approach that has been recently advertised more strongly in the tidyverse, and coupled with some features like across and see across that make that possible even more powerfully. So the very first thing I want to do is to work just with the columns that reflect life expectancy and get rid of the ones that that are not relevant to that. So remember that select has a bunch of friends, a bunch of helpers that allow you to refer to columns in a very expressive way. One of the helpers that we haven't seen so far is the starts with. So I can say, okay, take messy, right? And then select column continent, because I want to keep that column, but also select every other column that starts with lifex underscore. So if I run that, notice that I get continent and life expectancy columns, but nothing else. So that is, one way in which we have kept this kind of messy, wide structure of the data, and still we were able to do something with the tidyverse, to select columns because of these very handy tidy select helpers. So the next thing we might want to do is to clean up that prefix lifeexp. So say that if our entire analysis next, let's pretend that it's going to be about life expectancy, then the prefix life expect might be redundant. So let's think that is a challenge, so that we learn about this function called rename width. So the idea is to take all those columns and in one go refer to them and remove the lifeexp prefix. So how could we do that? Okay, there is a little function in the tidyverse 2, in a package that we haven't covered so far, called string r, that has this function called string str, comes from string replace. So what it does, it takes anything that you give it, or any string that you give it, it can be one or many strings, a vector of strings, and then it looks for some kind of pattern in the first argument, and then it looks for a replacement. So here are the arguments: string, pattern, replacement. The pattern that we choose is lifeexp. That's what we want to find, and then once you find it, we want to replace it with nothing. Basically, we want to delete it. So we can create that as a little function. So if we say .x is like anything, any string that we pass, we could use the syntax function to create that little function. So this is the first time that in this workshop we introduce the notion of function. Usually you see them written this way with the curly braces. I recommend actually that too, but you don't have to if it is so short that it does fit in less than 80 characters. So let's run that. So now with that little function, I could use that inside this very convenient function called rename width. So now I have a function to rename width, and I'm going to use that running this line here, 72, and let's see what that looks like. As you can see, I still have intact the column continent because it did not have any prefix that matched lifeexp. But then the others did, so they all were removed from that prefix. So that looks good here on screen, but on the console it doesn't look that good. I'm going to show you why. Because numbers are not syntactic names and not syntactically correct or acceptable names in R. Therefore, R has to add these backtick things. And this is generally a pain to work with, and you generally tend to avoid that. But because we have the tidy select helpers, then many times we don't need to refer to columns by the name specifically. We can refer to them, like for example, by the type and say, where is numeric? And then we are calling all those columns at the same time. So at least for the rest of this challenge, where I want to show how to work with awkward data, this actually adds to my argument that, no matter how, well, no matter what, even with very awkward data, you can still do useful stuff with the tidyverse, but it's not ideal. Better is to tidy things up first. One kind of alternative to creating this function that I created here is to create it on the fly inside the rename width. So rename width takes a function. So if the function is already a named function like this one here, that's fine, but it can also create it on the fly for you. And even more conveniently, although you can do something like this, so you could, this will work, right? This action here works. So you give rename width and the entire thing that you could put inside a function without a name, but it also uses a formula syntax. The formula syntax is this one. So with this tilde, is a shortcut for saying everything that I'm saying here, with a special condition that then you have to refer to the argument data as a .x. So that's kind of a compulsory thing. So that's it. So that's just to show off the ability to create what's called lambda functions, anonymous functions, functions that do not have a name, on the fly inside rename width. That's a function that I haven't had the chance to use yet in my real data science, but seems useful, so I wanted to demonstrate that as a way to work with kind of across columns row-wise. And that's also a very new feature of the tidyverse, so you may have missed it before. Now we are going to summarize the data, calculating the mean across all columns. So I'm going to show how we have seen the function summarize informally last time because of the excellent question by Daisy. But formally this was the first time I thought I would be talking about summarize. Summarize is very powerful. You can say the name of the column that you want to summarize, but now we also have across. So across will help you to refer to columns in your entire data set in a very now familiar way, which is using the tidy select syntax that you already know about. Things like where is numeric, or things like everything, or things like starts with. All of that is now available to you inside across. So the syntax that you're learning, you can reuse it now inside across to do these summaries across all columns. So the way it works in this case, I want to refer to, let's have a look at the data. I want to refer to all these columns, and we have done that many times already using where is numeric. So now, because it's so easy, it makes sense to say just where it is not continent. And the way it works, across takes a specification of the columns that you want to do something across, and that something could be summarized, but could also be, say, mutate, something like that. And then it takes a function. So what do you want to do once I have found all those columns? So in this case, I'm making a mean of across each. So in a vertical way across each of the columns. That's cool. So I have found for each year the overall mean life expectancy. That's cool, but generally Summarise is a lot more powerful when you combine it with group by. So let's do that. So ideally, you would want the total life expectancy per year, but also per continent in this case. So let's do a group by first. Now that we know how to group, and we can say across everything. That's another way to refer to all the columns, and actually that's the default as well of across. We can not see the default here, and we are also going to add one other column that is, we're going to rename it as n, and what's going to do is similar to count. It's going to count how many observations the summary is performed through, right? And that's going to be important if we want to calculate some kind of estimate of the uncertainty that our summary has associated. So let's run this bit first. And as you can see, we have achieved the following. We have one row per continent, and we have one summary per continent as well per year. We do have the column n, but it is kind of uncomfortable that by default it goes to the end. So with that, I'm going to demonstrate a new function as well in the tidyverse that is called relocate, which is one way in which just by mentioning the column that you want to relocate, you will bring it to the front. Usually, when you run an analysis, sometimes you're interested in very quickly having a look at what's the result they have achieved. So now I have n, the number of basically observations that were captured by this summary of life expectancy for each year and for each country. It is 52 for Africa, it is 33 for Asia, it is 2 for Oceania. And relocate is just a shortcut really for what it could be otherwise to do select, then the column that you want to bring to the front, and then everything, right? Everything, right? So if I do this, I get the same thing. It's just that it is more convenient and more expressive to say relocate, kind of more clearly shows your intent. So there we go, and we move on to working row-wise. So far, we have done this summary by continent that gives us this. So we have one row per continent with one summary of life expectancy per year. So what if we wanted to know for each continent what is the mean life expectancy through time? So that would mean to do a row-wise summary, right, across each row now, not across each column. So the function across knows how to work vertically, but we also have the function cacross that knows how to work horizontally. So in this case, we also need to group the data, but no longer we need to group it vertically with group by. Instead, we need to group it row-wise with row-wise. So that's just another way of grouping data. It is a specification of how the next actions with Summarise or Mutate should be performed. And if you print that row-wise to the console, what you see is, in the same way that group by said groups blah, now we have row-wise blah. It is just one kind of grouping. So we want to do something similar to what we did before, row-wise, and then create the new column life expectancy as mean. Here, what did we do before? Did we summarize? And we're gonna add a new column called life expectancy, and that we should hold the mean across everything. So the function cacross defaults to everything. So I could say cacross everything, just to be more explicit, but I don't need it because that's the default. So we are going to calculate the mean across all columns but row-wise, and then we are also going to calculate the standard error as it is expressed here. So basically what we want is to first calculate the standard deviation of the summary row-wise, so SD for standard deviation. So the standard deviation across all rows, and then we are going to divide that by the square root of n. So we have already n here, so that's where the number will come from. So the square root of that is how we divide the standard deviation across all columns. So with that, what we get is a summary made row-wise. Again, it's another demonstration that the data is awkward. It's kind of difficult to work. Row-wise is kind of more featured to work column-wise, but you can do it with row-wise approach in dplyr. So here we have the data set, and with this we could now plot the different continents as a bar plot on life expectancy. So we could know we could graph life expectancy for continent, not through time, just like a summary, and we could express with a standard error an idea of how certain we are that those means represent the real values. So let's do that. So let's create a plot with geom_call. So as usual, the ggplot, we start with ggplot, we specify an AS, and what we want is continent on the x-axis and life expectancy on the y-axis, and the geom that we're going to use is a geom that gives us a bar plot. There is two. One is geom bar that takes only one argument, and then that is x, because the y is computed, is a count. And then geom_call, which is the one that we want, that takes two arguments, x and y. So the two arguments to geom_call, I choose to pass them here at the top as a global definition of the aesthetics for all the layers in this case. And then, so let's start with that. That will produce something useful to begin with. So we do have a bar representing the mean value for each continent through time, but we don't still have any measure of uncertainty, so we want to add that. So there is geom error bar that can take the the minimum value and the maximum value along which you want to create a little error bar. So because the standard error is kind of symmetric, from the mean up and down, I choose to demonstrate that just by showing 1/2. So I'm gonna say, okay, the minimum value of my error bar will be exactly the top of each bar where the life expectancy is plotted, and then the maximum value is going to be the same life expectancy plus life underscore expectancy, is that correct? Yes, plus a little bit more, which is the standard error, right? So that's how I express that one here, right? So we have now error bars. That plot is almost there, except that in the plot itself, I don't have any information about which years this data is come from. So what I'm gonna do is gonna use labs to express a title here. So there is many labs that you can use. I'm gonna use title, and I'm gonna say something like mean life expectancy from 1952 to 2007. But you could also add, subtitles, captions, and a bunch of other things that will put strings of text in different places of your plot. So if you are interested, you can learn more, of course, in the help file. So here is our plot, and that was hard work because we were trying to work in a way that is unnatural for R. R is more column oriented, and we have been doing rowise oriented workflows. And here are the takeaways. So let's run that report again and see what we learned. Takeaways. Here we are. So this takeaway is wrong, something that I removed, so I'm not gonna cover, just the review that we use vroom. Working with tidy, so in terms of tidying data, working with messy data tends to be hard work. Luckily, we have some tools to deal with it, but generally it is much better to do what we did in the previous lesson. You work with the functions that come from the tidy R package: pivot longer, pivot wider, complete, fill. What else do you have there? Separate, unite. All those functions help you tidy things up, and then the tidyverse will be even more fluid. In terms of transformation data, we learn now about the helpers start with and everything, which I think I introduced before. We also learned about how to count things quickly. We also learned that group by is one way of grouping data, but it's not the only one. You can also group by rows with function rowise. And then you ungroup things with ungroup. You can summarize across columns, but in a kind of in a vertical wise fashion with the function across. And you can do something similar, but row wise with the function C across, combined not with group by, but with C with rowise. Also, the function N inside Summarise will give you the count, very similar to what you would do with the function itself count. And I presented also this new function rename width. It's even new for the tidyverse, that allows you to rename many columns at once using the now familiar tidy select helpers. In terms of visualizing data, there is two ways in which you can create bar charts. The one I showed today is geom call, and we learned about this new geom error bar that helps you to express uncertainty, and the labs function in ggplot2 that allows you to add a title, for example, a subtitle, a caption, and so on. We also learned that functions that output side effects should be designed so that they also return the same value that they were given, so that you can pass the input that they had, they can pass it to the next function in the pipeline. And we also learned about this. This is the only function that I will mention on the string R package that allows us to replace one string with another string, one pattern with one replacement. So that's the end of this lesson. We have plenty of time for questions, but we may also get started with the next lesson. And while I hear your questions, I'm going to create my commit. So go ahead and shoot your questions.
Thanks, Maro. So I just basically, I I haven't used the rowise. This is the first time that I've seen it. But what it basically handles is like another way to do summaries and to do counts, not along the columns, but like across the, not along the rows, but across the columns. Is it right? That's the only difference.
That's the only difference. That's right. Yeah. The motivation for that here wasn't very exciting, because that's something that you could have done just by tidying the data first and then do it in a more fluid way. But the next section is going to show, really show off the row-wise operations compared to an approach that is a little bit more awkward. So for very specific summaries, for example, for calculating many models on nested data frames that contain list columns, in that scenario, the new rowise approach is super elegant. It's not the only way. You can still work with other approaches, but I'm going hopefully to demonstrate how in those cases working rowise makes a lot more sense.
Okay, all right. And I guess another question that came to my mind, like during this last part, is about another way to do filters, because I've also seen that we saw actually in the previous part of the workshop that we can add many like specifications to the filter function, but I've sometimes also seen that we have actually many lines of filters in one single in one single calculation. Yeah. So for example, I have a database, and then I start doing a filter, and then I've seen that there is another filter just right after it, and then another one. Yeah. So why is that, and what do we actually do when we do like many filters?
Yeah, it's kind of very up to you. So sometimes you do need to first filter, then do something else, and then filter again, because in the middle that something else creates the data that you said you need to filter later. But sometimes it's just a matter of taste and a matter of choice. So if I do, let me print empty as table empty cars. Okay, so let's see what empty has now. It is this data frame here. So let's say that we want empty where MPG is less than, say, 18, right? So we have that now. And now, what if I wanted? Sometimes it's just fast to do something like this. You duplicate a row with the keyword shortcut Shift Alt and the arrow, and then you modify that. Well, you also want those where it is now, less or greater than. Or different column, like where this is.
No, that was actually a good example. Take it the same column.
Same column, okay. So MPG in this case, I wanted greater, so less than 18, but greater than, say, 15. Let's see what we get there. Okay, I filtered that. So that's one approach. Another approach, if I understand it correctly, and this is where I'm asking for you to confirm, I could do two things. This is one, and this is another one. So I could say comma, second expression, or I could say and second expression. All of these should be equivalent. Is that the difference that you were referring to? Why yes, this?
Kind of, but what I thought that it was that those lines that you had selected, what I thought that it was doing, it was just not changing the parameter that you are filtering for, but actually adding. So you have a filter, and then after that filter, you add another thing to the new data set that you are working with. So this is not doing it.
You mean adding a column, for example?
No, adding the subset. So you have the empty, and then you do the first filter, lower than 18, and then so you have five rows, and then if you do the next filter, you will have another 5 rows. these are the ones that apply the first parameter, and these are the ones that apply the second parameter. So it's not like that. It's not like adding sub-filters to your operations. I don't know if that's difficult to
maybe I think I'm not grasping fully what you mean. Probably what we could do is exchange a little example that you write later, and we can work with it. I'm kind of curious to see what that is. So if you can, unless you want to tell me what to type, but if you want, maybe just write it somewhere, and then we can discuss it.
All right, I will send you something later on.
Good. Yeah. But just to kind of wrap the point that I interpreted, basically all of this is the same. In this case, I was just saying that sometimes you find different calls to filter, but it's not necessary because the filter has this ... argument that allows you to add infinite number of expressions, each of those with like something that will filter rows by.
Okay.
Sorry that I failed to explain
No, that's fine. It's also hard for me to explain.
Okay, do we have another question before we kind of set up for the next lesson and go for a break? I do know it was super fast. It was kind of intentional. That's the speed at which we are working now. We are on a motorbike, so we're kind of fast. The next lesson is going to be the lesson on a car, so we can go very far with that, and it's going to show how to work with rowise in a way that makes more sense, like an application that you could probably see yourself using, and it's going to really focus on iteration. So let's go to that to the doc. So we're going to be talking about modeling, and we're going to use the approach rowise plus Summarise to create models inside the data frame in a data structure that is a data frame, but it is called a nested data frame because data frames are super flexible because they are lists, and lists are flexible themselves. So in a column, you can have a list itself, and you can have data frames themselves. So there is a lot of things that you can do inside the data frame, including creating models, extracting parameters of models, and things like that. So we're also going to be talking a lot about iteration in general. So I'm going to introduce the map reduce approach. That is an approach that helps you solve a really big number of problems. We are going to be using it to just demonstrate what vroom does, kind of to decompose what vroom is doing. But the excuse is just an excuse. It's just to show map and reduce. So how you can iterate over things when you can't use group by, for example, what do you do? Or even if you can, sometimes you choose to use a list-oriented approach as opposed to a kind of more data frame-oriented approach. Even if you work on a nested data frame, because a nested data frame contains a list inside, contains a list column, and we're going to talk about that. We're going to continue to see some of the functions that you saw before, but we're going to learn about this nest by, which is a function that creates that nested data frame. You're going to learn about the last, or the fifth of the 5 main dplyr verbs. We talked about mutate, we talked about filter, select, group by, and now arrange and summarize. So all of those are the main dplyr verbs. We are also going to learn about modeling with LM, which creates linear models. We're going to talk more about map inside mutate as one way of creating models in the data frame. PMAP, I'm not going to cover PMAP. I'm going to be covering IMAP, which is a shortcut for EMAP2. So EWOC and EMAP. I'm going to talk about that later. Actually, let me see. I will fix this. In terms of visualizing, we are going to learn, we pretty much learn everything we need to know about plotting. It's just, to learn more geoms, you just go to the website and help yourself. The general template, how to create geoms, and how to facet data in different panels. What you haven't learned yet, like some tweaks that you can do with themes. So we're going to be using theme black and white, but you can choose from any number of themes. There's quite a few, and you can create your own. And we're going to be saving plots. There is a convenient function from ggplot called ggsave, Although you could save it in other ways, that's a convenient way to do it. And we are going to do it in a very, I believe, elegant way. When you have many plots and you want to plot to say one file per plot, how do you do that programmatically? Finally, in terms of communication, we're going to use this cool feature that we learned about, parameterized R Markdown reports. And the interface we're going to build is one where you have a slider and your user can use the slider to create a range, in this case, a range of years, over which your report will produce an output. And the file we're going to be working is 5 cars U. So we have still 5 minutes. So in that time, I'm going to set up, because the last lesson is long. So no, the better I start, the better. The sooner I start, the better, because otherwise I will be kind of flying through it. And although I acknowledge that it's meant to be fast, maybe it could be a bit too fast. So where I'm at, okay, I'm here at the project, I'm on the master branch. Maybe I would like to, at this point, let's close this for now. I would like at this point to do a PR pull upstream, just to make sure that I'm synchronized with everything, with my upstream, and I'm good to go. And then I would like to initialize, unless I have done it before. I don't think I have. Let's see if I have a branch. No, I don't have a branch 05 car Mauro, so I will create it now. So 05 car Mauro is going to be the name of my branch. It is also going to be the name of the file I'm going to work with. So the first thing I do, I go here to the file I want to work and create a copy of that, removing the prefix and changing the suffix. So that is a change that now the text gets as something that it doesn't know about, but now I add it to the staging area and create a little commit like add my car file and hit commit. With that, I'm ready to create the pull request with PR push, and that will send me to GitHub to complete the try again. We attempted to a window, but the action was prevented. It looks like my browser didn't like it that much. I'm going to create pull request and create here a draft pull request, because this is just work in progress. And now you see the label draft. So I'm good to go. That was all that I needed to set things up. So let's go to the file itself and render it. So let's go to the very top of the file, and you can see that there is a bunch of parameters that this report is building on. So remember, we are in the last lesson now. We are talking about pre-advanced features. Parameters is not particularly advanced. It's just a very simple way to access some of the beauty of Shiny. Shiny is this framework for interactive reporting and interactive data science in general. So the thing I would like to show off, so maybe just do that as a goal for the rest of this block, this last 3 minutes, is to click here on the need button. On the drop down menu, you will see the need with params, and that will make those params available to the user of this report from outside the report. So the user can now choose, in this case, a range of years from this case, I don't know, let's say 1970 to the end, and need that report. And let's see what that would give us. The report, it says, has a figure that shows the year, so I should be able to see if the change is reflected in the report. So let's go to here. Yeah. So here, as you can see, the plot starts more or less around 1970s, which is what we chose in the interface, and ends past 2000. The end was 2007. And let's now plot in a different range to see the difference with parameters. Now let's do all the way from 1952 to say 1980-ish, where I was born. Let's need that. And let's see the report again. So what we should see is that the plots now show a different range in the x-axis, and all of that from outside R, which is great, because if you want to share your report with a stakeholder, and the stakeholder has questions that they can answer themselves just by choosing different parameters. Like, for example, what was revenue for last month? They just change the month and they get the answers that they want. So here we see the plot. So what we are looking for is to convince ourselves that the parameters that we use actually were reflected in rendering a new report with the parameters that the user used from outside. They don't need to know R, they just need to know how to point and click. So as you can see, the report does show data from the very beginning of the range, which was 1952, all the way to 1981, actually, which I selected. So, okay, with that, I let you go for a break. I'll stay here for a couple of minutes if you have questions.
Thank you, Mar. I think I'm gonna log out because it's just too fast, and I would like to dedicate the time to go through each function and understand it better. But many thanks for the training. It has been like super helpful, and I hope that I will be able to work on all the stuff that you have taught us today soon. Thanks.
Thank you, Laura. It was a pleasure to have you here.
Thank you. Bye all.
Okay, little break at the top of the hour is the last lesson. It's gonna be again pretty fast. Hopefully for some it will be the speed that you were looking forward, and for some it might be a bit too much. But at least you can have you can just passively see what's going on, what are the limits of what you can do, or the non-limits of what you can do, and hopefully whenever you need it, you know where to look for information. So I'll see you in 10 minutes.